Okay, so we're going to talk about two potential limits today. Okay, so the first one is the limit as x approaches infinity. Right, Chess? And the limit as x approaches negative infinity. Okay, so we're basically looking at the end behavior of our functions. Okay, so like what's happening really far away. Okay, so I'm going to start it out with a function that we know what it looks like. Okay, we'll start this with number 1. Okay, if I asked you what the limit as x approaches infinity of negative 3x squared plus 2x minus 5 is, what would you tell me?
Wait, the negative.
Okay, so how did you know that? Okay, so you're hopefully thinking about what this looks like, right? Okay, so if we think about what this looks like, it's basically an upside down parabola. Chess. Okay, so if I'm looking as x goes to infinity, the far, that right side, his right hand, where is that right hand going? It's going to negative infinity. Okay, so basically, when we're going to infinity, when our limits are going to infinity, we need to know the end behavior of our functions. Okay, so the functions that become more interesting are ones that have horizontal asymptotes. Okay, so the first thing I'm going to do is show you how to find horizontal asymptotes, and then that'll allow you to find limits at infinity. Okay, so we'll call this finding horizontal asymptotes. Okay, there are 3 scenarios. Okay, and I'm going to do this by example. Basically, these scenarios happen with rational functions. Okay, so when I say with rational functions, do you remember what rational means? Right. So functions that have fractions, right? Okay, so that's when you see horizontal asymptotes. Not always. There's other kinds of functions that do have horizontal asymptotes, but mostly. Let me think. Let's say 3x squared plus 2x minus 5 over 4x to the third plus 2. Okay, so does anybody remember what you're looking at to decide about horizontal asymptotes? The degree, good. So basically, all you're going to do is you're going to look at the leading term on the top and the bottom. Okay, and you're looking at the exponents. Okay, is the exponent bigger on the top, bigger on bottom, or is it the same? Bigger on bottom. So if we have this scenario where the exponent, I don't know if you need to tell yourself that, the exponent is bigger on the bottom, it'll always result in the same asymptote. Okay, you'll always have a horizontal asymptote at y equals, does anybody remember? At 0. Good. Okay, no matter what. Bigger on bottom, horizontal asymptote at 0. Okay, scenario number 2. Let's say we had it switched around. Okay, so this time our exponent is bigger on top. Bigger on top. Okay, now this will be a unique scenario. Okay, depending on the function. Does anybody remember what the scenario is?
Oh, you subtract them.
Subtract them, no? I'll give you a hint. There's no horizontal asymptote. So therefore, what is there? Not a hole, a slant asymptote. Okay, so there's actually a way to come up with the equation of the slant asymptotes. Okay, but we're not going to get quite into that yet. We eventually will. But for now, all you need to know that a slant asymptote is telling you that the end behavior is either going up to positive infinity or to negative infinity. Okay, so we can see that by graphing. Okay, our third scenario would be what? When they're the same. So let's say we have 4x cubed plus 2 over 3x cubed plus 2x minus 5. So if the exponents are the same, that also is a unique case. We do have a horizontal asymptote. Anybody know what this one would be? Good, 4/3, nice. Okay, so do you see where the 4/3 came from?
Question. Do we have to worry about any of the other exponents?
Huh.
Is it just
the other terms, like after the leading term, basically give you more local behavior, so it can cause a function to potentially have vertical asymptotes or wiggle or whatever. But the two in the front describe the end behavior, so we can completely ignore those and just look at those for horizontal asymptotes. Okay, so everybody okay with 4/3?
So how do you figure out what the next one is?
The next ones.
Period of the
The period?
The next one.
What do you mean by the next one?
Horizontal asymptote.
Where the next horizontal asymptote would be? There's only one on, usually. It's possible to have a 2 asymptote, and I'll show you an example of 2. But usually you only have one horizontal asymptote, or slant asymptote. Okay, so let's do a couple examples. I think we're on number 2, right? Okay, so let's say we have the limit as x approaches, let's go to negative infinity this time, of 2 over x minus 5. Okay, so we're working with a rational function. We've got a horizontal asymptote. Tell me about the case that we're working with. Is the exponent bigger on top, bigger on bottom, or is it the same? It is bigger on bottom because there's no x's on the top, right? So 0 x's on top, 1 x on the bottom, so it's bigger on the bottom. So case 1, so where's my horizontal asymptote? At 0. So that tells me that if I have a horizontal asymptote, both ends are going to 0. Okay, so my limit as x approaches negative infinity is 0. There you go. Okay. So horizontal asymptotes describe end behavior. Round 2?
Re-explain? Like it has an x, so it's bigger on the bottom. So
Right, because how many x's are on the top?
None.
None. How many x's are on the bottom? 1. 1 x is bigger than no x's. Okay. Let's try this one. The limit as x approaches, let's go to infinity, of 4x to the 5th plus 2x over, it's hard for me to make things up, 3x to the 5th minus 8. Okay, so which case are we looking at? Good, good, good. So they're all the same. They're the same. So we're just using the coefficient in the front. I might have just made that the exact same as my other example. Dang it. I'm not creative at all. All right, let's try another one. So let's try the limit as x approaches negative infinity of negative 2x to the 3rd plus 5x over x plus 1.
Slant.
Okay, so bigger on the top, we have a slant asymptote. So basically at this point, if I know there's a slant asymptote, I know my end behavior is either going to be going to infinity or negative infinity. Okay, so I really have a 50-50 here. I can graph it and just look what's happening as x goes really far to the left. Or I could use a little bit of algebraic thinking. So let me show you how you would do the algebraic thinking part. Okay, so again, as we just talked about, the leading terms are going to describe your end behavior, right? So if I basically use my first term of the top and bottom and plug in a really small number, let's call it negative infinity, even though that's not really technically a number to plug in, all I'm going to be looking for, is it going to be a positive number or a negative number? Where is it going? Okay, so if I plug a really, really small number into the top, would I get a positive or a negative? It would turn positive, right? Because we have negative to the third is negative and then times the negative, so we'd get a positive. Okay, and if I plug a really, really small number into the bottom, I get negative. So since I have a positive over a negative, that tells me where is it going? To negative infinity. So this is that same kind of test that we did when we were working with the vertical asymptotes coming in from the right or from the left. Same idea. What else? Oh, let's do one where it has two. Let's see if I can think of one. Example 5. Okay, so a square root. If I have a square root of a fraction, what would I do?
Just ignore it.
Can't completely ignore it. Kind of, but I want to think about reducing the function first. Okay, so do you see how the inside can kind of reduce? So again, we're just looking at those leading two terms. Okay, I have an 8x squared over a 2x squared, which would result in a 4x squared, right? And then if I square root it, what's the square root of 4? 2. Okay, so we have this asymptote, and I kind of alluded to this already, that this is, oh look, I'm so creative. I created the exact same example. 5x, let's see if I can do this. Did I say plus 5x?
Yeah.
And then on the bottom, I just have minus 8.
2x squared.
Minus 8. Okay. So I typed this in as a squared over a square root. I don't know why I typed it that way, but it would be the same scenario, right? Okay, so this is what this function looks like. Oh, this one only has one asymptote. Where is my one horizontal asymptote? How about 2, yeah. So at 2, let's see if I can think of one that will have 2. So this one would be 2. Okay, so let's see. One that would have 2 is where you would have a squared on the top and not one on the bottom. Let's do negative infinity. Let's try 9x squared plus 5 over x plus 2. Okay. So do you see how in this one, if I was going to like reduce the first term, if I have like the square root of 9x squared, if I took that, it would become what? I took the square root of it. It would turn into 3x. So then I'd have 3x over x. So which case would that be? So like if I have 3x over x, that would be a same case scenario, right? So I would technically have a horizontal asymptote at 3. Okay, so check out this one. This is kind of cool. Let's just kill that one. So it would be the square root of 9x squared. I don't know, remember what I wrote after that? Plus 5. And then divided by x minus 2 plus 2. There we go. Okay, so this is one that has 2 horizontal asymptotes. Look at how funky that looks. It's like an hourglass, but kind of like a check mark. Okay, so this is 2 horizontal asymptotes. The top one, the one going to the right, has a horizontal asymptote at 3, and then the bottom one has one at -3. So it's describing the end behavior. It's only going to go to one spot, but because of the square root, there's 2 of them. Okay, so this one you would have to look on and see, okay, wait, I went to -infinity, right? The limit as x approaches -infinity. For this one, what would my answer be? So the left side, where's the left side going? -3. So this one's going to -3 because we're going to -infinity. Pretty easy stuff. It's kind of a good Monday morning one.